Alright, so here's a problem from section 3. We see this problem, we see that it's a proper fraction. We would maybe try to factor these things. Again, this is a dx, not an 8x. So what we're going to do, the top we can't factor, the bottom we could factor. We're going to integrate this thing eventually, but let's just look at the expression that we have here. So we have x squared plus 10x plus 3 all over. This will factor, looks like an x squared minus 3 and an x squared minus 1 is what we're looking at. And so now we have to figure out how can we break this up. Using the partial fraction decomposition, since I'm dividing by a quadratic and I can't break these up anymore, I would have a ax plus b over the first term followed by, looking at my problem, this should be a plus. Okay, and so that just makes things a little bit better later on. So again, I just changed that to a plus 4x squared plus 3. So that changed my factory down here to a plus 3 and a plus 1. And then I'd be adding to it this next piece of a cx plus d over x squared plus 1. So now I have to do the partial fraction decomposition, the solving systems equations part. So that means that ax plus b is going to get multiplied by the denominator x squared plus 1. Cx plus d is going to get multiplied by the x squared plus 3. So I have a ax plus b that's going to get multiplied by x squared plus 1. And I also have cx plus d that'll get multiplied by x squared plus 3. Doing the math on this, should get ax cubed plus bx squared plus ax plus b. Foiling out that bottom one, cx cubed plus dx squared plus 3cx plus 3d. Looking up above, we know that I do not have an x cubed term. I see I have an x squared term, and a 10x and a plus 3 is a constant. So when we go back down here, we know that a plus c is 0. I also know that b plus d, that was 1 because I had one x squared term. Right there I have a plus 3c. That was my coefficient for my x term, which is the 10. And then I had b plus 3d was my constant, and that was 3. So now, solving a systems of equations, we should be able to figure out what a, c, b, and d are. Again, I'm going to want y'all to check me up on this, but you need to know how to do this. But I found that a was -5, c is 5, and b is 0, and d equals 1. So that's what I found when I was doing this. And so now we can go back to our original equation that we had, way back up here, right? And we're going to set what this is equivalent to. Again, we have ax plus b and cx plus d. So let's see how far we can get with this. So I have the integral of x squared plus 10x plus 3 over x to the 4th plus 4x squared plus 3 is equal to, so it was ax plus b, so negative 5x plus 0 over, my ax plus b was over the x squared plus 3, and then cx plus d, so I had a 5x plus 1 over the x squared plus 1. And this is all with respect to x. So this first piece, if we split it up, because we have the sum of two functions, the first piece, we can integrate that. Again, you're left with the negative 5 integral of x over x squared plus 3. And this we should be able to do with a simple u substitution, letting u equal x squared plus 3. du equals 2x, dx. And then, again, manipulating this somehow so it becomes a 2. Again, y'all know I'm a fan of saying 2 over 2. So 2x dx is our du. This 2 we can bring out, so it would be a negative 5 halves. So this one is integratable. What we have to worry about now is this 5x plus 1 over x squared plus 1. So let's look at that. 5x plus 1 over x squared plus 1. I just can't let u equals x squared plus 1, because if I do that, I get 2x dx. I don't have a single term. I have a binomial up top. So what we're going to have to do is possibly rewrite this. Let's say that this is equivalent to 5x over x squared plus 1 plus 1 over x squared plus 1. So they both have the same denominator. I just split up the numerators. This one I can use a substitution to factor just how I did a second ago. This one here, like, this is the definition of arctangent of x. And so I think in your answer, you're going to have something with the natural logs of some of these denominators we got on this page and then the previous page. Right? Because it'd be the 1 over u, natural log of u. And they might have combined them together, which I'm pretty sure they did. So we'll have some natural logs, but this last piece is just the arctan of x. And again, we're going to have some plus c on the end. So this is one of those questions in section 3 that we use in arctan. There are totally different ways that we might have to manipulate these. Let's say if we were dealing with the 3 over an x squared plus 6x plus 2. If we were doing something like this, we would have to manipulate it to get that x squared plus 1. I think me and Fu were playing with this one the other day. So if we completed the square on the bottom, we take half the middle term and then square it. So I'd have 3 over x squared x squared plus 6x. So half of this squared would be plus 9. But then I'd have to subtract 7 to it to make this equivalent to this. So this I would rewrite and say is 3 over x plus 3 squared minus 7. Which we would have to manipulate a little bit more to get in that form of x squared plus 1. That 3 I'm going to go ahead and take out. But if I wanted to make it an x squared plus 1 is something squared plus 1, I'd actually have to factor out a negative 7 in the denominator. So now that negative 7 in the denominator, I could pull out, and I'm left with a u squared plus 1 in the denominator, which would be an arctan of that value. A little bit trickier type problem, but one using a substitution step. So that's a problem from section 3, and hopefully this has given you a little bit of ideas on how to do one of these partial fraction decompositions dealing with the arctans, and even if we had to use some completing the square techniques to help us find an answer.